Now for our next speaker. I find this one personally very interesting because I would have never ever thought that I have the opportunity to speak to an astronaut. Quite often, I associate astronauts with America. But of course, in Europe, everything possible is also done that we're part of exploring space. But what's the connection between space and climate? We're going to hear this from our next speaker, material scientist and astronaut of the European Space Agency. Please put your hands together for Matthias Maurer. Welcome, Matthias. Where would you like to stand? You have a choice.
Well, I join you here on that side. Good afternoon, everybody. I'm very happy to be here and have the chance to report about my personal view from space. It's a very unique vantage point, and I think, well, I hope I can inspire you to take more climate action, because definitely we need to take action.
Absolutely. I've actually prepared some questions as well. Let's just go through them. So the first one that I am curious about is that in the history of space travel, less than 700 people have been in the altitude of space. You're one of them. So what led you from Germany to the European Space Agency in Paris?
Well, I believe nowadays a lot of kids have this space dream. They want to fly, they want to see the world from the third dimension. My case was a bit different because I come from a rural area and I thought like astronauts are Superman, and so for me this dream I didn't even dare to dream when I was a kid, and that's the first mistake. Usually you can only achieve a big dream if you dare to dream, and we all should dare to dream to save our planet and to achieve the 1.5 degrees temperature increase limit. So, but later on I learned that ESA was looking for astronauts when I was already an adult. And nowadays, astronauts are scientists in space. We are engineers who work with the best technology. We work in international teams, because only internationally we can achieve what we want to do. Mm-hmm. And obviously there's also the adventure related to riding a rocket to space. And that entire package made it very appealing to me to become an astronaut.
Thank you very much for revealing that private insight. So, you spent about 177 days on space travel. Can you share with us your perspectives from the world, climate from above? And can you see climate change from above?
I think we have a small video prepared for this one.
Yeah, let's have a look.
Good point to show this one.
Yeah, let's have a look.
Alrighty. So we see up there from space, I have a vantage point where I can see like roughly, well, we're flying at 400 kilometers altitude in 90 minutes once around planet Earth. Mm-hmm. So every day I have 16 times sunrise and sunset. And it's very emotional to see planet Earth with your own eyes. I mean, we all see the video, we all see photos, but once you see it with your own eyes, it touches your heart. Mm-hmm. And I've not seen a single person up there in space looking down who had not wet eyes, like a tear in your eyes when you see planet Earth for the very first time. When we're up there, we're ambassadors for humanity. Mm-hmm. We can work in a team, and when we can achieve stuff that no country, no single nation can achieve by its own. Mm. So we're the ambassadors of our planet Earth. And from the vantage point of being up there in space, we look down to planet Earth and we think like, this is also a spaceship, just a very big spaceship, but a perfect spaceship. And we astronauts, we know that we only can succeed if we work as one team. Mm-hmm. And for us, it's so obvious. Planet Earth can only achieve to master all the challenges if we also act as one team here on planet Earth. Yes. Up there from space, you don't see any borders. You look at Earth, the globes that are hanging here, and it makes me dream again. It's like, this is our home. It's the unique place in space. It's the only place where we can live. There's no plan B. And looking down, you want to protect this planet.
Thank you so much. That touches me, what you're telling me, because sometimes we just take it for granted, having our feet firmly on the ground. And I really appreciate you actually sharing that perspective from the climate above. What does the astronaut actually do in space? What is the day-to-day activity of an astronaut?
Yeah, when you see these pictures, you think like, it's a nice place to watch planet Earth, and that's what we're doing in our spare time. But we're actually working from 7:30 in the morning till 7:30 in the evening. It's science, science, science. I participated in roughly 150 different experiments. Most of them are related to material science, fluid physics, and also to human medicine. I myself, I'm a guinea pig. It's like a lot happened to my body in space much, much faster than what happens to a sick person here on the ground. For example, older persons very often have bone loss. So grandmother falls and the hip bone is broken. But very often it's the hip bone breaks and she falls. And this is called osteoporosis, and it happens also in space 30 times faster to us. And so we need to do action and we need to learn. And so we bring back the knowledge from space to the ground. And I would like to share one experiment which I did in space, which is also relevant for climate change. We all know that building industry has a massive impact on climate change. It produces so much CO2. The concrete production, cement production worldwide is a large factor. And one of my experiments was actually to mix concrete in space. Not because we were going to build a space station with concrete, but in space you can look at materials at a different vantage point. Because there's no gravity, you have no demixing. And concrete is a mixture of gravel, of sand, of water, of cement powder, and other stuff. Mixing it here on the ground, it demixes before it hardens. And that leads to an effect that we cannot simulate concrete in computers. But to optimize a material, you want to simulate it. And so I mixed concrete in space. I created pure samples that were up to 30% stronger even by accident. So imagine now we transferred this knowledge down to the ground. We could immediately transfer it to a 30% reduction in concrete and a 30% reduction of CO2. That's one of the ambitions that we have from the vantage point.
That is, there's so much to unpack there, what you just said. First and foremost, the health risk cost, and of course, the cost of your life as well, that you spend in space in order to help us here in Earth to find solutions to problems. That is itself amazing. And the second of all, I would love to see how the mass looked like when you mixed the concrete. What was it? Was it jelly? Did it harden? How did it end up?
Well, it looks a little bit like here on the ground, but you're right. A liquid in space, because there's no gravity, it always forms a bubble.
Yes.
And so when we release a drop of water, it forms a bubble. It's always a sphere, it's round. And in order to achieve the best scientific samples, we needed to house it in a package. And so it needed to be contained. Otherwise, there was the risk that the cement powder floats away and it floats in my eyes or in my lungs, and then I would get some damage out of it. So yeah, doing experiments in space, it's a bit more complicated than down here on the ground.
Yes, I can imagine. You have to think things from different perspectives, absolutely. But that's why you're a scientist, right? Well, and since we're talking about that you're a scientist, a materials scientist, you can determine how new materials can best serve and improve humanity, like the concrete that you just mixed. Other than that, what have been your findings so far?
Well, doing material research in space, we can do conditions or create conditions that we cannot create here on the ground. So we're developing new alloys that are lighter, but more resistant, stiffer. So a new car engine, a new plane engine. We always want to have a better material that allows us to be more energy efficient. And this is all part of the space research. But I think the most important part of space research comes not from the astronaut, it comes from the satellites. Because the entire fleet of satellites that we have up there, and Europe is one of the leading satellite providers for Earth observation. We have the Copernicus constellation. it delivers 80% of all the data that we need to understand climate change. And then we couldn't imagine anymore a day without space. For climate and energy distribution, you also need to have the GPS signal, like the navigation satellites, because they give you a timestamp, and this timestamp is important to regulate and control the energy grid, and also the logistics for all the railway systems. Everything depends on space. And so you see, using space data, you can improve the distribution of energy, the need of energy, and you can also improve like the forecasting, where will you need energy or where will you need more resources. For example, city planning uses satellite data, and they can forecast, okay, the city is going to grow in this direction, we need to have more infrastructure in this area. You can use satellite data also for farming. In some areas, using the satellite data, you can say like, okay, this area needs more moisture, otherwise my crop will die. So to optimize it. Space has a lot to offer. Outside we have some stands giving you already some products, but there's so much more, and everybody here who has not been involved or not looked into space applications, I would highly encourage you, because space can offer so much.
You've definitely encouraged me to look more deeper into this, because you've just highlighted so many activities and role plays that an astronaut delivers for us here on Earth. And, you know, why is space for our topic, climate from above, so relevant? What's the correlation between space and climate? You've kind of broken it down, but in a nutshell, what's the correlation?
Well, it's first of all the data. We get the data so we understand where we are with the climate change. And we get other data that can now be combined with artificial intelligence that help us to distribute the energy that we have more efficiently, and also to make better use of our resources that we have on planet Earth. But also we can use space to create a new source of energy, and that is our space-based solar power, our project Solaris.
Okay, now that is a new interesting finding, what you're revealing there. I'm hoping to hear more about that. Now, you brought along with you another film. Can we have a look at that?
The sun, the source of energy for life on Earth. Stored in fossil fuels, the sun's energy has powered modern civilization for over 200 years. But the use of fossil fuels has resulted in dangerous global warming and a changing climate, to the extent that the United Nations and the European Union have declared a climate emergency. Transitioning to clean energy is an urgent imperative, and Europe is committed to achieving net zero emissions by the year 2050. But this will be extremely difficult if we rely only on existing renewable and low-carbon energy solutions, as intermittency of supply, pressures on land use, scalability and toxic waste limit how quickly and effectively existing energy sources can be rolled out. The European Space Agency has been investigating a new solution that could overcome all these problems. Solar power delivered wirelessly from space to Earth. Europe has the technology lead in building and launching communication satellites. This deep know-how can be built upon to develop and scale up solar power satellites. Huge orbiting solar farms, built up of many similar parts that will be mass-produced, launched into space on low-cost, reusable launchers, and assembled together in orbit using advanced robotic techniques. Once completed, these satellites will collect the full power of the sun's energy 24 hours a day, 7 days a week, and beam it wirelessly down to Earth to receiver stations, which will turn it back into electricity and deliver it to the grid. Space-based solar power is thus a continuously available, inexhaustible, sustainable and scalable source of energy that could help Europe meet its climate and energy security goals. This is not science fiction. The fundamental technologies are understood and are already being demonstrated on Earth and in space today. However, there are still many engineering and policy challenges that would need to be overcome to make this ultimate energy source a reality as early as the next decade. Other nations are already working on realizing space-based solar power. If Europe also wants to benefit from this game-changing capability, accelerated investments in research and development would need to start now to determine if space-based solar power can indeed offer another source of affordable and abundant energy for our green future. And in doing so, launch a new European space energy industry that would provide enormous opportunities for innovation and economic growth in space and on Earth.
Indeed, that does seem to be an amazing proposal. But listen, Matthias, I'm not going to lie. Can you please break this down in layman's terms, what Solaris is about?
Yeah, it sounds pretty much science fiction. And 80 years ago, that was the very first time when people dreamt about this space-based solar power. It was pure science fiction. Nowadays, the technology is there. But we still need to look into more technological advances to make it affordable. Mm-hmm. So we have solar power in space. To create the solar power, you need solar cells. And in space, a solar cell needs to be lightweight, not like the heavy solar cells that we have on our roofs. And the lightweight cells, they're there, but they're still a little bit too expensive, so we need to come down with the cost. And then in space, we want to produce the same amount of energy per solar farm as a nuclear power plant on the ground, so gigawatts. Mm. So that means imagine 2 square kilometers solar farm in space. Now you have the energy and you need to transform it into a microwave. And the microwaves are beamed down to planet Earth. So also there we still need to learn how to make the efficient conversion from the electrical energy into the microwave. It's beamed down to the ground, and there again, it needs to be reconverted into electrical energy, and that again also needs still some technological development. It is all feasible. Japan is working on it, China is working on it, the US is working on it, ESA has a project, and the advantage would be you have 24/7 always clean energy coming down from space. So let's imagine in the northern part of Europe, there's wind energy, but there might be a day when there's no wind. So you could tilt your beam and send the energy where it is needed. And then again you have wind, and so okay, now I tilt my beam and I send the energy to a different country that needs it. So it has a lot of advantages. There's no need to store the energy. There's no toxic waste like in nuclear energy, but just needs to be done.
I can imagine that someone here in the audience could potentially collaborate with the ESA, yes. European Space Agency. So hopefully you will still remain during the course of today with us here. Just to close it off, what's this issue about space debris?
Yeah, so we all talk about planet Earth and how to protect our climate, how to protect our seas, our air, our water. We also need to protect space, because space, it seems endless, but the valuable space around planet Earth is also limited. And right now we have around 10,000 active satellites. Wow. Half of these satellites are owned by SpaceX, by Elon Musk. And he's planning to set up 42,000 satellites. Other providers as well want to send up satellite constellations. So in the very near future, we will have 100,000 satellites, like 10 times more than now. And that all leads to the fact that we're all fighting or looking at the same orbits. Mm-hmm. And when a satellite runs out of steam, out of power, it just remains there. And then it is debris, it is waste, and it's garbage. It takes up valuable space. And then there's the risk that debris hits other debris. and then it creates thousands and thousands of pieces, shrapnel, that again can like destroy other satellites. And so space is getting more and more filled up with space debris. And if there's too much, and if we don't learn how to clean it, then we will lose access to space. We would lose access to all the valuable data for climate change. And so we all need to take care also about space, to keep space clean. That is so important. And also that every country in this world has access to space. It's not limited to only a few of us.
Thank you so much for sharing your perspective, your ideas, for enlightening us in what everything is being done so far, and also the fact that, of course, space can also be polluted, which will be detrimental as well. Thank you so much for your time. Matthias Maurer, everyone. Thank you, Matthias. Now, I'm still amazed to learn what everything is being done so far in order for us to come towards, how did they say it earlier? Isn't it the Marshall Green Plan? Perhaps the ESA plays there a significant role.